All right. Somebody give me a... Actually, we won't do that. We'll do it this way. We're going to put a point on our unit circle. We are going to put the first point at 1, 1. Now, do not put the dot on there yet because I want to make it slightly bigger than you want to make it. So put it somewhere around the middle of the axes that you have. And we're going to call that point 1, 1. Now, as in all math, when we have number, comma, number, we know that we are dealing with coordinates. And those coordinates are x and y, yes? Okay. X gets written first, y gets written second. I just want to write this in a different spot. We're not changing what we wrote, but for what I am about to do, I would like it written in a different spot. 1, comma, 1. Everybody cool? All right. Now, on the left-hand side in quadrant 2, please give me negative 1, 1. I'll use a different color for that. And then I'm sure you know where the next one's going. Negative 1, negative 1. And the last one is going in 1, negative 1. All right? Everybody cool? Easy peasy lemon squeezy, yeah? Okay. Now, with just this first one, from the origin, make a terminal arm that goes through 1, 1. Everyone agree? Mm-hmm. All right. Now, make that red terminal arm the hypotenuse of a triangle with the initial arm on the x-axis. What did we just make? Triangle. Excellent. What kind of triangle? Right triangle, which means what? It means it's got a 90-degree angle. It means I can do trig with it, yes? All right. So where is theta? Right in there. Agreed? Okay. So what is the sine of theta? No.
You know that it's 1 unit and 1 unit for the opposite.
Right. So how would you find the... How do you find the hypotenuse?
You can do cosine or sine.
No, you cannot.
Yeah, because we know that that's 1 unit and that's 1 unit. We have the opposite and we have the adjacent because each is 1 unit.
Oh, because I used 1, you know that that's 45, yes. But what if I didn't use 1? Then you would have to do what?
I'm saying that we have to do more trig, but I'm saying...
No, you don't have to do more trig. That's what I'm asking. What do I do to find the hypotenuse of a triangle? Pardon me? Pythagoras. So what is the hypotenuse of this triangle? It is 1 squared plus 1 squared, yes? Then square root that. Well, what is 1 squared? 1 plus 1 squared. 1. What's 1 plus 1? So this is the square root of 2, yes? Everyone agree? Okay. Now, how long is this side? 1. How long is this side? 1. So now, again, I ask you, what is sine theta? Always. Opposite over hypotenuse. Excellent. So sine theta is always opposite over hypotenuse, yes? Okay. What is it in this case? One over 2 squared? 1 over root 2. Agreed? Now, look, we're going to stop there for a moment. What is cos theta? Adjacent over hypotenuse. And what is it in this case? Excellent. What is tan? Always. Opposite over adjacent. And what is it in this case? 1 over 1. Everybody cool? Easy peasy, right? SOHCAHTOA trig, yeah? Okay. Now, do the same thing with my black, with the black triangle in quadrant 2. What is this distance? No. -1. What is this distance? 1. What is this distance? Yes, you do. Negative? Why is it the square root of 2? If that's negative? Well, you can have negative 2 has a square root?
No, because it's going towards the up in the y-axis. So,
how do you find the Pythagoras? How do you find the hypotenuse? How do you always find the hypotenuse? You use Pythagoras, which is what? A squared plus b squared equals c squared. So what's a squared here? What's -1 squared?
oh my goodness.
What's -1 squared?
That is insane.
Positive 1. What is 1 squared? Positive 1. What is a squared plus b squared? Square root of 2. Wait a minute. So what is the black sign? 1 over root 2. What is the black cosine? No. -1 over root 2. What is the black tangent? 1 over -1. Now you should be starting to see a bit of a pattern. What happens in the blue one? They're both negative. So what is the sign of the blue one? -1 over root 2. What is the cos of the blue one? -1 over root 2. What is the tan of the blue one? No. -1 over -1 is? Positive 1. And finally, what is the green one?
It's the same thing as the second quadrant, just on the y-axis.
What is the cos, the sign? What's the sign? -1 over root 2. What's the cos? 1 over root 2. And what's the tan? -1 over 1. Yeah? Okay, now look closely. There's a whole bunch of stuff going on here. Remember, all of these used, wake up. All of these used 1, right? So, look at this red one, x, y. Look at the red. What do you notice? There, 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 and there. They're all 1s. Great. What do you notice on the black one? I should have made that blue, sorry. What do you notice on the black one? -1, -1, 1, 1, 1, and -1, right? What do you notice on the green one? Talk to your neighbor, because by now I shouldn't be hearing silence. When you see something 3 times, you should be able to put it together. Talk to your neighbor and notice the pattern that you are seeing, because it's going to happen a 3rd time down here. A 4th time, I mean. So I should hear some murmurings with your neighbor so you can talk. All right, who would like to talk to me? Lena. They're the same as x and y, aren't they? So not only is sine O over h, it's also y over h. What's cos? X over h. And what's tan?
X over y.
Look again. Y over x. So if you ever have coordinates, you also know these. But there's a bit of a problem there. What is that problem? Does the x and the y automatically give you the h? No. Still got to work it out. So knowing what you know now, go down to our, I'm going to shrink this down so you can all see it on my screen at once, even though it's all on your page at once. Down here, label the quadrants. 1, 2, 3, 4. Yeah? Okay. And then draw, just sketch. It doesn't have to be perfect. Do not get out a compass. Sketch a circle. Now pretend that's a perfect circle centered right on the 0. Centered right on the origin. Now, of course, I can do a perfect circle if I so choose. Except the computer froze, so anticlimactic as usual. So you've all drawn your perfect circle, I hope. Well, you've sketched a circle. Such a piece of crap. I'm just going to go back to my sketch. Except I can't even do that. All right, now, please, while I am waiting for the usual thing I am waiting for, which is my computer to do something simple that I have asked it to do, I want you to have a look at this circle that you have made here and notice that it intersects the axes 4 times, yes? And each of those intersections is the measurement of what part of the circle?
9 degrees.
No. Yes, it is the radius of the circle, right? So at all of these intersections, you know you've got a radius, yes? Okay. What did I just draw? Another radius, yes? Okay. Now, take that and make a triangle out of it. Everyone agree? Okay. What do you know about this distance? You know only 2 things about it. Who would like to tell me what they know about this distance? Even my red dot is gone. There. I got time. Talk to your neighbor. There's 30 of you in here. One brain in this room knows something about that distance.
I know.
What?
It's positive.
It is positive. Excellent, Jalem. What else do you know about it? Because I said you know two things.
It's not the whole
Anish.
Oh, wait.
Okay.
Wait. The hypotenuse equals the radius because it would follow that point on the circle.
Well, that's where I'm going.
Oh.
You're 3 steps ahead of me, but
Okay.
good job. I'm talking only about this part.
Okay.
Jalem has said it is positive. I would highlight it, but it will not let me get my pens visible because it's a piece of crap. So I have to rely on my dot there. I'm going to try closing it and see if maybe it will work when I reopen it. So anyway, Jalem has already said that it is positive, so that should help you out. Positive what?
Positive.
I'll give you a little hint now.
Radius.
It is not a radius.
It's only part of the radius. It's at 0.
I'll try another hint.
It's at 0 on the y-axis.
Now you're getting warm. I've already told you that Jalem is right. It's positive. Positive what?
Positive 3/4 of the radius.
Positive what? X. Excellent. This distance is x. Right? Because it's on the x-axis. You have no idea what it really is. Correct? What is this distance?
Y.
Positive y. Correct? Great. What is this distance? Now that is a couple of things. What is it? It's the radius. What else is it?
The hypotenuse.
The hypotenuse of a triangle. What else is it?
It's blue.
What else is it? Thank you. This is the square root of x squared plus y squared. So now you can do all kinds of trig on here with just a single point. Right? Now, since x is positive and y is positive, in quadrant 1, what's positive? Sine, cos, or tan? All of them. So in this, all sine, cos, and tan are positive. Now your smart kids, fix this up. What happens if I go over to this side? They're not going to be all positive because what is this? Negative x. And what is this? No, it is not negative y.
Well, I'm not looking. Sorry. What?
Perhaps you should look before you speak, and then you will not sound unintelligent. So over here, sine is positive, but cos and tan are negative. What's going to happen down here? What's this y? Negative y. So, what is sine? Negative. What is cos? What is tan? Positive.
What? Oh, opposite or adjacent.
There you go. And over here, x is still positive. What's y? What's y? Negative y. So in quadrant 4, what is sine? Negative. What is cos?
Positive.
Positive. And what is tan? Negative. Which sets us up another memory tool like SOHCAHTOA. What's positive down here? C. C. What's positive here? All of them. A. What's positive here? Over in quadrant 2, because I left my red dot over there. S. And what's positive down here? T. C-A-S-T. Or, well, cats goes kind of zigzaggy like Zorro. Everybody cool? Everybody good? Everybody good? Yeah, you could say acts if you want to go that way. I don't care. I was taught C-A-S-T. So that's what I still say. You want to say A-C-T-S, acts, that's fine, I don't care. Or you could not use a memory tool at all and just use your brain. When X's and Y's are positives and negatives. Now, the question is, why are all the hypotenuses positive?
Because even if you square a negative number, it's going to be positive.
Because when you square a negative number, you get a positive anyway. Aight? Everybody cool? That's why this section is called the unit circle. Because if I make all of these 1, like I did up here, it makes a circle, and you can do trig with it. Okay? Everybody cool? All right, turn the page over while I try to make my screen bigger and have it maybe not freeze. Okay. You now have the following points on the terminal arm of theta. I'm going to draw the first one just to show you what I mean. 4, 0. 4, 0. That is the terminal arm, and it's the initial arm. So what's theta? 0 degrees. It hasn't moved at all, has it? Okay. So sine is x. I lie, not x, you idiot. What's sine? Y over hypotenuse. Well, the hypotenuse here is 4, isn't it? Because I only went there. There's only one measurement, correct? So the y value is 0. Yes? And what's the hypotenuse? 4. What is cos? Which is 4 over 4. What is tan? O over A? I don't have O's and A's. I don't have O's and A's. I have X's and Y's. You just did this on the previous page, ladies and gentlemen. It was a minute ago. 0 over 4, y over x? Okay. So now, check with your calculator what happens when you do the sine of 0. 0. What is 0 divided by 4? 0. Excellent. Now, check what happens when you do the cos of 0. 1. What is 4 divided by 4? 1. Amazing! What happens when you do the tan of 0? 0. 0 divided by 4? Brilliant! Now, what's going to happen with b? What is the sine? What is sine? 3 over 0. Yeah? Right? Y over hypotenuse. So the hypotenuse here is 0. The hypotenuse here is 0.
Because we don't have the y.
There is, there is 0, 3. There's no distance there. It's 3. So what's the hypotenuse? 3. Right? So it can't be 0. So again, obviously this needs to be drawn again. 0, 3. It's right there, yes? That's the terminal arm. So there's the initial arm. So what angle am I dealing with? 90. What is the cos?
0 over 3.
3. 0 over 3. And what is the tan? Just look back on your previous page if you can't remember. 3 over 0. Now, look on your calculator. What is the sine of 90? Lo and behold, it is 1. 3 divided by 3. Holy crap. What is the cos of 90? 0. 0 divided by 3. Holy crap. What is the tan of 90? Error. Why?
Because the tangent doesn't deal with
What's happening here?
tangent equals opposite over adjacent, and the tangent.
What's happening there? What math is that? Division. Can you divide by 0? No, because it's infinity. So that makes sense, doesn't it? Okay. Try this again. Some issues here. I have an x, I have a y, I'm missing a hypotenuse. You just 2 seconds ago told me how to find the hypotenuse. How do we find the hypotenuse? X squared plus y squared, and then you square root it. So, what is the hypotenuse in letter C on the next page? 5. So now you know x, y, and h. So what is the sine?
-5.
0 over 5. What is the cos? -5 over 5. And what is the tan? 0 over -5. And the last one, what's the hypotenuse? 2. So what is the sine? -2 over 2. What is the cos?
0.
And what is the tan?
-2 over -2.
All right. Are we all good? Have we done anything new?
No.
Not really. We already knew about x's and y's. We already knew how to find hypotenuses. We already know SOHCAHTOA. So we're just looking at it differently. Right? All right, now let's see what we can do with real ones. What do I have right there? What have I just highlighted? I have highlighted an x and a y, which means as soon as I have x and y, what can I make? A hypotenuse. So my x equals -4, my y equals 11, and my hypotenuse equals the square root of what? -4 squared plus 11 squared, which is 16 plus 121, which is 137. Square root of 137. So there's our hypotenuse, because we don't want a bunch of crazy decimals. Everybody cool? Great. Now tell me what the sine is. The square root of 137. Tell me what the cos is. Negative 4 over the square root of 137. Tell me what the tan is. 11 over negative 4. Now tell me, in which quadrant does this lie?
2.
Why? Because you have a negative x and a positive y, and because you have a positive sign and the other two are negative. Everybody good? You try the next one. Sketch and determine the value of the standard position angle whose terminal arm passes through 4, negative 3. So let's sketch it first. Where's 4, negative 3?
Fourth quadrant.
Fourth quadrant. 4, negative 3. 4, negative 3. So what is the triangle that we have? It is that, correct? Okay. So what is this distance? What's my x? 4. What's my y? Negative 3. What's theta? This is tricky. What's theta? Talk to your neighbor. This is from yesterday. Where's theta? I don't know. Where's theta? Read the question. The arm I just highlighted is what? Terminal arm. Where does every angle begin? The initial arm, which is along the x-axis. Where is theta?
Along the initial arm and the origin.
Thank you, Damaris. Theta goes all the way around here.
Okay.
Except I can't do that, can I? Because when I do this, with this triangle, what am I finding?
The angle that's coming inside.
I'm finding the oh! Go get yourself a gummy bear. This finds me the reference angle, which is what? What do I have here? What parts of the triangle?
You can do inverse tan.
I'm going to use tan. Why?
Because you have the opposite.
Because I have x and y. So I'm going to do inverse tan, shift tan of what?
Y.
Negative 3 over 4. And what's that going to give me when you do that on your calculator? Shift. What's that going to do for me? Shift, tan, negative 3 divided by 4. What's that going to give me? Negative 37, yes? Now you've got to use your brain. You know that that's the reference angle. Since it's negative, you know you've got to count clock or counter clock. Clockwise. So you know you have to go clockwise 37 degrees. Which means if my reference is 37, what is my theta? Theta equals 360 minus reference. 360 minus 37, 323 degrees. Now let's check. Tan 323. If we're right, what should it equal? No. Look at the work we've done. No. Talk to your neighbor. What did we shift tan to find the 323? Pardon me? We shift tan the opposite over the adjacent, which was negative 3 over 4, yes? Which is negative 0.75, isn't it? So when I tan 323, what should I get? Negative 0.75. Let us check. Good gravy. I did. Does everybody understand? Well, that's all the decimals because remember we rounded to 37. Now watch this. Shift tan negative 3 divided by 4. There, right? 360 minus my answer, which was my reference, yes? Oh, wait, crap. That's probably not going to work. Yeah, that didn't work. I needed to do 360 plus because it's a negative, right? So 360 plus bracket, shift, tan, negative 3 divided by 4, close brackets, equals 323.13, yes? Now, tan of the actual answer, 323, not the rounded one. Everybody cool? Now, what does that tell us?
I have no idea.
It tells you something. How? Oh, sorry, Veronica? Yeah, that's what I just proved. But what does that tell us about the nature of angles? This line right here had two different tan values, didn't it? One was for the reference, and one was for theta. So what does that tell you about every angle?
The reference of theta add up to the other 360 degrees.
Yeah, but what does that tell you about the trig part of things? You've just seen it once. Let's do another one before I ask that question again. Go to the next question on page 77. What do we know? We know the terminal arm lies in quadrant 2. Where's quadrant 2? Top left, right? So let's just draw a line out there. We know it's going to be out there somewhere, yes? Now, what do we know about that line? We know its tangent is that. What do we know about tangent? It's opposite over adjacent if we were at the beginning of grade 10, but we're in the middle of grade 10, so what is it now?
Y is 9 and x is 5.
It is y over x, yes? So the y value is 9 something, the x value is 5 something. If we're in this quadrant, which of those is negative?
X.
The x. So this is negative 5. And what's this? 9. Everybody agree? Okay. Now, how are we going to find where, I should say, is theta? Red or blue?
Blue.
Blue. Which one can I find using trig? Red. How?
Inverse tan.
Shift tan of what?
Y over x.
This fraction, right? So negative 9 over 5 will give me red theta. What is it?
Wait, don't you mean 9 over negative 5?
Doesn't matter.
Doesn't matter?
They're both going to give you the same negative decimal. What does that give me? Negative 61, right? So, that's a reference angle, yes? Where do reference angles live?
On the other side.
They've got friends on the other side, yes.
Reference on the inside.
Where do reference angles live? Between what and what?
So reference and
The closest x-axis and the terminal arm, yes? So if that's a reference angle, I must go to my closest x-axis, and it says it's negative. What direction's negative? Clockwise or counterclockwise? Clockwise. So I got to go that way, 61. Which means, what's
180 minus 61 equals the reference.
this? Has to be 180 minus 61, which is 119. Is everybody good? So what does that tell us? Sine, cosines, and tans are going to work in various places and do various things for us, yes? This section will help. Use your calculator to do all of these. Yes? 4 decimal places. Don't make me give you a lesson in rounding. You do that with your calculator. Sine 43 equals, or 43 sine, depending on what kind of calculator you have. Then tell me what they all are. To 4 decimal places. You're doing 8 of them. Who has some answers for me? What's the first one?
I'm looking at B and C.
6, 8, 1, 8. 6, 8, 2. Because it's 681,998. So 6820. What's 170?
I got a question about B and C.
Just do them. Just write down the numbers. I'm going somewhere with it.
Okay.
That's all you got to do. Your question's going to be answered in a moment. What is 170? Negative 0.9848. Yes? What's 350? Positive 0.9848. What's 10? Or what's D?
This is so cool.
0.1763. What's E? Negative 0.682. What's F? Negative 0.682. What's G? Error. Undefined. And what's E?
That is so cool. I think I get it.
Now, what do you notice about some of those numbers? There's a couple of things to notice about some of those numbers. Luke, hit me with one thing about some of those numbers.
Okay, some of them are the same because of the different places on the quadrants that they have. So even if they are, if 43 and 223 are far away in the different quadrants, it's closer to this an x-axis that makes it the reference angle that many degrees.
Yeah. So Luke is discussing the same ones. What do you notice, Jalen?
I just have a question. How do you make your calculator not round?
That's a pain in the ass. We'll sort it out later. Damaris. Some are negative and some are positive. So let's look at some of these. Where are 2 that are the same? B and C are the same? I would look closer. E and F are the same, yes? So let's have a look at E and F. E and F are the same. So let's have a look at that situation. Where would 223 be?
Third quadrant.
Third quadrant. Down here, yeah? Everyone agree? What do I know about that? I know that all the way around is 223, and I know that the reference angle is 43, yes? Everyone agree? Okay. Where is F?
It's on the fourth quadrant.
Fourth quadrant. Down here. What do I know about there? Oh, I wanted that to be red, of course. F. So I go all the way around to 343 or 317, but what's the reference angle? 43. Wait a minute. 43, 43, and I got the same numbers. Now look at A. What's A? Positive 0.682 with the reference angle of 43, right? Wild. See what's happening?
43s are everywhere.
No. 43 isn't everywhere. Reference angles are everywhere. Does everybody understand? Let's look at another one. What else is the same? D and H, right? Okay, so we had D and H. D and H. Draw 'em. Where's D? It was 10, correct? So it'll be right there, 10. Reference angle's 10, yes? Where's H? 190, right there. Reference angle's what? 10. Crazy! Picking up what I'm putting down?
How did people create such a cool thing?
People didn't. It's just the way it works. And then look at B and C. Why are they opposites? 170 and 350.
Because one's got
So B and C, B and C. B was 170. Where's that? Right out here. What's the reference angle?
Yeah, but it's negative x, that's why.
What's the reference angle? 10. And C was 350, right? What's the reference angle? 10. Why was C positive?
Because it's positive on the x-axis.
Because it's positive on the x-axis and it's in the cos quadrant. Why is it negative over here?
Oh, because it's negative in the cos quadrant.
Negative, it's a negative cos quadrant, but the reference angle is the same, so the decimal's the same. Because the decimal only comes from the division of the numbers, yes? The negative comes from where it lives on the coordinate grid. Does everybody understand? Just like 1 over 2 is always 0.5. But if I go to the left, it's negative 0.5. If I go to the right, it's positive 0.5. Is everybody good? Aye. Garumph. All right, turn the page over. Now use everything you know to tell me what theta is and sketch it. Damaris.
For the last ones, can you figure out whether your number is going to be positive or negative just by looking at the degrees, like your if you're using sine, tan, or cosine?
Yeah.
Your degrees, and then figuring out which quadrant it is.
Yes. Do I need to sketch it right away to do number 6? Yes or no?
No,
Why?
because you already had enough information to write it out.
Because I have sine theta as that. So can I not just shift sine right away? Can I? So to find theta, all I can do is shift sine negative 2/5, right? Let's do that. What do I get? Negative 24.6.
Why are you saying,
So what would we do with that? We'd round that off to negative 24. It's 23.6, right? Everyone agree?
but hold on, why are we shift signing it if we don't know the hypotenuse? Because it's...
You do know the hypotenuse. The hypotenuse is 5.
Oh, I thought that was 10. Never mind.
No, that's why it says sine. Everybody cool?
10 minutes. 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 10 minutes
That's easy, right? We know it's negative 24, but negative 24 is not a measurement, is it? Negative 24 is not how we measure an angle. How do we measure angles? They're positive, because we're always looking for theta, right? So, now we're in trouble. Because now, we all knew what to do. Our calculator found us the angle, right? Have I finished the work? No. Have I proven that I've listened just a little bit to my math teacher?
Yeah.
Yeah. I find the angle by doing shift sine. That's a 1 out of 4 on the 4 scale, isn't it? Because that shows no understanding, correct? Now we have to sketch it. Since sine is negative, where are the only places it can live? No, it can't be in the second quadrant. Second quadrant is where sine is positive. It can only be in 3 and 4, yes? And since sine equals y over h, and h is always positive, I know I'm going down here, and there's my 5. Where's my negative 2?
It's got to be in the third quadrant.
It's got to be there and there, correct? Everybody agree? This has to be my negative 2's to get my y over h, yeah? Sooner or later it'll show up. Everyone agree? Now when I shift sine, I'm going to get my reference angles, aren't I? Yeah? So I know that that is 24 and that is 24, correct? So what are the two possible thetas I have? There's that one. Because a reference angle, you go to the closest x-axis, negative, clockwise, 24. Right? What is it? What's red theta? 204. What is green theta? $336. Which is the right answer, or are both the right answer? Both are right. How do you rewrite this question so we get one answer? What is the 3 words I would need to add to this question so we would only find one answer? I'm going to get rid of the period. What would I add to that? In the blank quadrant, right? If it's in the third quadrant, it's 204. If it's in the fourth quadrant, it's 336. Is it possible that this was in the second or the first quadrant? Why? Because sine is negative. So it has to be in 3 or 4. Is everybody with me? What if I change that sine to cos? Where would it have to be negative? If I change this to cos, where would it have to be for cos to be negative? 4 or 2. What if I changed it to tan? Where would it have to be? 2 or 4. Everybody cool? Once again, please notice we haven't done anything new, have we? It's still opposites and adjacents. This says assignment, but you're just going to do it. And that's your homework tonight. 79 and 80. Go diddly-o. You got 25 minutes. There should be no reason for anybody to take homework home from me tonight. Sometimes you're trying to find theta. Read the question.